Welcome to Physics Can Be Fun with me, Stephen Thomas. I'm carrying on a second lesson on vertical projectile motion in one dimension. And as we go along, I'm going to just make it a little bit more difficult. So here again, we have our building, we have our base jumper. Things accelerate downwards, changing their velocity by 9.8 meters per second every second. That is what we call acceleration due to gravity. But again, till we get the complete hang of it, and it's very easy to make the changeover, let's just work with 10. Okay, 9.8, close as anything to 10. Now there's the second type of situation I'd like you to get used to. And that is where our person throws a stone up and then it starts to come down. Right? So do you get the idea? So the person throws the stone, and I'm going to take it from the top of the building. I could take it from his hand. Here we have time t equals 0. Somewhere around here is going to be t equals 1 second, t equals 2 seconds, and t equals 3 seconds. So we're going to follow the stone for 3 seconds. And let's just suppose that the stone is thrown upwards at a velocity of 3 meters per second. Just for the sake of interest, we could choose any number, but let's choose 3. So its starting velocity upwards is going to be equal to 3 meters per second. Now, it's very important with these kind of problems to choose a direction as positive. We normally choose the starting direction as positive, and it starts with the stone going upwards. So let's choose up is positive. Right, so it's starting with a positive velocity of 3 meters per second. Now that immediately brings us to the problem that g therefore must be, in which direction does gravity act? Does it act up or down? Well, if up is positive, g is negative or down. So this is going to be minus value minus 10 minus 9.8. Do you get the idea? We're working with something that's flying upwards as a vector, starting velocity, and gravity acting down. They're in opposite directions. One's positive. We've chosen up as positive because it's the starting direction, and therefore down must be negative. Now let's work it out. What is happening is that every second the velocity is changing by minus 10, right? It's losing 10 from what it started with. So after 1 second, if we start at time equals 0, our velocity is equal to plus 3 meters per second. What do you think after time 1 second the velocity will be? Well, it loses 10 from each second, from its starting velocity. So what is plus 3 minus 10? It's going to be minus 7. So after 1 second, the velocity is going to be minus 7 meters per second, or 7 meters per second down. Do you see how easy that was? And then after 2 seconds, what's the velocity going to be? Well, every second it accelerates by minus 10. So its velocity is going to, if it was minus 7, it's going to add on another minus 10, which is minus 17 meters per second. And at time t equals 3 seconds, what's its velocity going to be equal to? Adding on another minus 10, it's going to be equal to minus 27 meters per second down. You see how simple that was? And so that is how we can figure out the velocity. Now, what would the displacement be? That is slightly more difficult. Can you think of how you would work out the displacement? Well, you're going to have to use a calculator. And let's take as an easy case, what's the average velocity of between 7 and 17? Well, add the 2 and divide by 2. 17 plus 7, 24. Divide by 2, 12. So the average velocity downwards, 12 meters per second, or negative 12. So they're going to fall on average 12 meters between here and here. If you do the same, what is the average velocity between minus 17 and minus 27? Well, add the 2, 44, divide by 2, 22. So it's going to fall 20, it's going to have an average velocity of 22 meters per second. That means it's going to fall 22 meters in that second. And so you can work out the distance that the object is going to fall in each particular time period. Let's see if you can do the same. What is the difference between plus 3 and minus 7? Well, let's follow the same pattern. Add the 2 and divide by 2. So minus 7 plus 3 is minus 4 divided by 2, minus 2. So in the first second, the stone is going to fall, minus means down, 2 meters. So in this period of time, between starting and there, it's going to fall minus 2 meters. Between here and here, adding 17 plus 7, 24, divided by 2, it's going to fall a distance 17 and 7, 24, divided by 2, 12. It's going to fall 12 meters. 27 plus 17, 37, 44, divided by 2, 22 meters. And so our displacement, that is how our displacement is going to change. In the first second, it's going to fall 2 meters from here. It will go up a little bit and then come down and then end up 2 meters below the building, start at the top of the building. Minus 2, after the next second, we add on minus 12, which is minus 14. And after the third second, we add on the 22, which is going to be minus 22 plus minus 14, 36, minus 36. So it's going to have fallen 36 meters down the building. And so we can actually work these things out with just sheer logic. But in the next lesson, we'll show you we also have equations of motion which make it easier. We don't even have to think this through.